All right, the 7th period video. This would be the 4th video of the day, for me anyway. And so this one's the easy one to keep up with. These are just the multiples of 4. And we may do a few here and there, like on either side, if I want to use it to make a point. Number 4. State the domain and range. Okay, domain is the x value, so it's like what x values does that cover? Well, I guess the first thing is this going to be an interval or is it going to be a list of values for number 4? It's going to have to be an interval. All the other ones are lists of values, but I can't just list out everything between 0 and 10 or 0 and 11. I don't know which one it's supposed to be. I guess I'd take either one, but I think it's 11, so we'll go 0 to 11. If you said 0 to 10, that'd be fine. Because I don't want to just list out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because there's still 1.5 and 2.73. There's an infinite amount of numbers between 0 and 11. Range, that'd be the y values from bottom to top, so that looks like -2. I'm going to say to 9 just so I keep it 11 by 11, that way it's a circle. But again, if you said -2 to 8, that would be okay. Domain and range. Determine whether it's a function. Is that a function?
No.
Definitely not. Why not? I just kind of answered that question. Yeah, not a function. Fails the vertical line test. Vertical line test, if you hit it more than once, then it's not a function. Each x goes to more than one y. If it is a function, determine if it's 1 to 1. Well, that question doesn't matter because it's not a function. Number 8. X equals -2. So that would be this graph. Domain and range. So what x values does that cover? What x values does it cover? -2. Only -2. What about range? What y values does it cover? So that needs to be an interval because it covers all of the y values. Is that a function? No. How badly does it fail the vertical line test? Infinitely badly, correct. I'm not sure that's proper grammar, but yes. The vertical line test is an epic failure, right? Because at the vertical line -2, it hits it everywhere. If we think back to our like vending machine diagrams, our mapping diagrams is kind of what they're officially called, where there's the independent and the dependent. What goes in the independent? -2. And what goes in the dependent column? Every single y value ever. So you couldn't really even draw this because you'd have to draw like an infinite number of arrows, right? Like I drew 5 or 6 and I'm out of space. Again, it is infinitely not a function. This would be a fun vending machine, right? As a user, right? Because when you push the button -2, what do you get from the vending machine? Everything. It's glorious. But it's not a functioning vending machine. The other question is that discrete or continuous? Do you know? That seems to be a tricky one. Continuous. How do you know it's continuous versus discrete? If it continues. What about number 4? Is that discrete or continuous?
Discrete.
So discrete means you can list off all the points. You can't do that. That's continuous. 5, 6, and 7 are all discrete because you could just list the points. Number 8, you could list some points, but you couldn't list all the points. So it's continuous. I guess another way to say it would be if it's discrete, you could do the mapping diagram. If it's continuous, there's no way to do a mapping diagram. I mean, without sort of fudging some things. I'm just saying all real numbers in there. Number 12. f of negative 2. Function notation. Remember, whatever's in parentheses goes in on the other side. So f of negative 2 means kick out the x and replace it with negative 2. So that would be negative 4 minus 1 would be negative 5. That's the easy one. Before you turn the page, I want to look at 14. F of d. So now you're not plugging in negative 2. You're plugging in d, but it's the same process. But instead of negative 2, you put a d in there, and your answer is 2d minus 1, and there's nothing you can do with that. So that's just it. Which of the following is the graph of a one-to-one function? Okay. Is a graph of a one-to-one function? Well, you have to determine function first, and then you figure out if it's one-to-one. So is A a function? Yes. Is it one-to-one? No. One-to-one, you can do the horizontal line test. So it's not one-to-one. Although it was a function, it's not one-to-one. How about graph B? Is it a function? Yep. Is it one-to-one? I think so. Let's check the others. Is C a function? No, it's not even a function. Be careful, though, because if it passes the horizontal line test, right? So if you skip and just say, oh, I'm just going to check the horizontal line test, that's a little bit misleading, because it has to be a function before you can think about it being one-to-one. So this one's not a function, and therefore it's not one-to-one. But it kind of passes the horizontal line test, so be careful with that. D, definitely not even a function. So we were right. B is our answer. It's a one-to-one function. Okay, promise we'll come back to 17 and 18. Number 20. Oh, landed on an easy one to start, this one. I always hate saying easy and then grabbing popsicle sticks, because someone's going to feel bad if they don't know. But I have, well, not infinite faith, that'd be a lot. But I have faith in Artine and Emilio. So Artine, tell me one of the changes to number 20. Right 2. All right. Emilio, give me the other change.
The 2 makes it a stretch, right? Or
yes.
I forgot what it was.
Well, which one? Yep, that's your question.
It's a stretch.
It's a stretch. So a vertical stretch. Okay, so I need to go right 2, and then stretch it vertically. That's sort of my new slope, but it's going up. Didn't get flipped, so up 2 over 1. And then I think I've said this before, but I'm lost track because I've said it 4 times already today. Double check that your graph matches what you said would happen. That seems silly, it seems easy, but I promise you, almost all of the mistakes, like very few people make a mistake coming up with the transformations. And then somehow, from the transformations to the graph, sometimes there's like a breakdown somewhere, which is frustrating when the student gets their paper back and they're like, I knew what happened, I just didn't graph what happened. And I'm like, I don't know either, because you knew what was supposed to happen. So just take a minute, 5 seconds to check. Went right 2, and I stretched it, so I feel good about that answer. I'm convinced if you would take the extra second to check that your picture matches your words, you'd catch a mistake. And maybe it happens when like there's lots of things going on in like 22, so maybe you forget to account for one of those even though you wrote it down. Maybe that's it. Put that again in 24. We've got 3 things going on in 24. Put those so you can see them. So, Jacob, tell me one of the things going on in 24.
Vertical stretch.
Okay. Vertical stretch. Moises, what else is happening?
Left 2.
Left 2. And Abby, what's left?
Down 1.
Down 1. Okay. Down 1, left 2. Left 2, down 1. Vertical stretch. Still no flipping on this one, so just stretching it by 2. And again, double check that your words match your picture. Got the stretch, got the left 2, got the down 1. Now, some of you, maybe this is the problem, but some of you aren't going to check because you're not even going to write this down. You're just going to go straight to the picture. That's okay. It makes it a little harder for me to give you partial credit if you mess something up, because I won't know that you thought it was supposed to go left 2. But if you do a quick little note to the side, like I can give you like half points, like, oh, they knew what was supposed to happen, and then they messed something up over here. So it doesn't specifically ask for these all the time, but I think it would be wise if you put them there. That way I can partial credit, and I think it will help you, not mess something up. Let's see, I think you can still call popsicle sticks here. All right, Kaylee. How about number 4 on that last page? I can put 2 people on that one. Get lots of popsicle sticks done today. Vanessa, awake back there? 'Cause you're up next. Wake her up. Do it. You guys are too kind. I don't know that I'd yell in her ear, but certainly if you dropped a textbook next to her, that'd be okay. Back to number 4. Kaylee, what's one of the things changed about number 4 from the parent function? You flip it. I'm going to say flip vertical to be more precise. Trip, what else is going on there with number 4?
Am I talking about what type of graph it is?
Yeah, it's okay. What are the transformation? Let me specify the question.
It's a vertical stretch.
A vertical stretch. But since you were going to offer, what type of graph is it?
Wasn't offering.
You were scared that was the question. Somebody help him. What type of graph is that? Quadratic. So what's it look like? Parabola, yeah. This was a good question from earlier. I will expect you to be able to name the transformations of that, but I won't expect you to graph that, because we did not get any practice graphing transformations of anything other than absolute value. So I expect you to look at that and know, hey, that's a parabola that's flipped and stretched, but not enough yet to get it precise enough to have to graph it. You could get an idea, what it roughly would look like, but we're not going to ask you to graph them yet.
What if you have horizontal stretch in between, absolute value?
So if it was, let's just do one thing at a time. Like that would be okay, so that's a separate problem, but that would be a horizontal compression. And a horizontal compression results in a vertical stretch. And you could see that on this one, because you could do the math here. If you squared that out, that should be the same thing as 36x squared, which now that looks like a vertical stretch. Those graphs should be the same. Those graphs are the same. One just looks like a horizontal compression change. The other looks like a vertical stretch change. But those are kind of the same thing. So that's kind of this unique thing of, which one is it? Well, kind of both, but it depends on how you write it. And I'm going to have to be careful when I grade, because if it's one of those, I'd have to accept either answer, because they're both correct. All right, Vanessa, number 8. What's that 1/5 do to the graph? Good. Vertical compression. then number 12. Ooh, we got some horizontal stuff going on in number 12. Cubic, so that means y equals x cubed. The parent function. Reflect over the y-axis. Y-axis is this way, so the reflection is left and right. So my negative needs to be on the inside, needs to be with x, with the x. And a horizontal shrink by a factor of 1/8. So how do I accomplish a horizontal shrink by a factor of an 8?
So -1/8 times.
It would just be 8 because the inside stuff is backwards. Right? If we multiply by 8, it actually shrinks it up this way. That's the answer. We should stop there. If we wanted to get creative, I'd have to know what 8 cubed is, and I don't. My calculator does, though. 8 cubed. 512. So that's the same thing as negative 512x cubed. So you could say this is a vertical flip and a vertical stretch by 512. So that's a really extreme stretch, but so is a multiplied by 8 that way. But I wouldn't write that. It wouldn't be wrong. It's just like, why'd you do the extra work? Just go with what they said. Okay. Now, that concludes the video portion of the day.